Hello and welcome to our second Zoom meeting. Thank you all for being here. So just as before, I'll work the Zoom with two devices. One so that I can show you my writing and go through problems, and the other so I can better monitor the Zoom meeting. As always, when you're in here, you're muted so that I don't hear any background noise. I know we're all in our homes, are very much alive, so there is noises of the people living with us, plus also we move our computers around and it picks up all that noise in the microphone. So you're all muted, but it doesn't mean I want you to stay muted. If at any moment you have a question, just feel free to unmute yourself and ask a question. If you're shy about asking questions, I totally understand. I get shy in Zoom meetings too. You can go ahead and move your mouse around and you should see a chat little box, and you can always go ahead and post your message there. I just sent a message so you can see where the chat is. I wrote, "Hi everyone." And I'll have the chat box open so I can monitor the chat. All right, so let's go ahead and get started. So I sent you via announcement an attachment, and that attachment was a review of your exam. Now for your exam, what you will see for your exam is actually a multiple choice exam. I thought for this first test, just to make sure we're comfortable with the material and with the idea of having a test online, I figured a multiple choice online would be the best choice. Originally, I thought to make two parts, one multiple choice, one open response, but I think I'll save that for test two. So only one test, multiple choice. So for your instructions, you have 20 questions in your exam, and they're all multiple choice. You're allowed 3 hours, so 180 minutes, and you're given 2 attempts. The exam, I'm giving you a week. The exam is due Thursday, October 1st, with a cutoff time at 11:59. So make sure you're done before 11:59, not starting at like 11:50 because it shuts off at 11:59, just like your homework. During our Zoom meeting, I will work out the problems that have an asterisk. If you would like to see any other question done, feel free to just ask and I'll do it. It's not a problem. I just, in my head, I'm thinking I shouldn't make Zoom meetings too long. I read something about experiencing Zoom gloom and it being exhausting for both all people there and all people who are hosting. So I don't know. I just don't want you to feel tired. I don't know what your other schedules look like or your other teachers, what they're making you do. So I try to keep my Zoom meetings within an hour, hour and a half. And my tests, I give you plenty of time and also always give you a week to complete every assignment because, again, I do not know what you're experiencing at home or in your other classes, your other workload is. All right, enough talking. Let's go ahead and do some problems. Oh, I remember seeing a question if someone asking if it's going to be monitored or some type of way proctored. This will not be proctored. So just take it when you can. In the future, I might use other proctoring devices or attachments and stuff, but not for this one for sure. So yes, have your notes out. Make sure you have everything handy. Have this reviewed out when you're taking the test so that make sure that you're doing well. All right, let's go ahead and start. The first problem I have an asterisk on is this inequality with absolute values. So when we have an inequality with absolute values, a lot is going on, but it's not said. And there is no hint to tell us what's going on. We kind of just have to remember. So remember, whenever you have an inequality with absolute values, we have an argument to consider. What do we want? Do we want or do we want and? Which one is it? Well, all that is said by our inequality. So if I have greater than or equal to, we have or. If I have less than or less than or equal to, I have and. And depending on which one we have, I don't know, I feel like a hair on my nose. That's keep touching my face. Depending on which one we have, it tells us what argument we want. So for or, it's anything shaded, that is our answer. And for and, it's only if they overlap. If they don't overlap, there's no solution. So these are always, for me, I'm always like, okay, I have to remember all these things before I even start. Okay, I haven't even started and I have to make a note. I know that this is an or argument, right? That's what we have. Okay, so for an or argument, I have to make sure first that my inequality is, no, my absolute value is isolated. So I want to get that by itself. And yes, my inequality, I keep saying inequality, my absolute value is isolated. Okay, once it's isolated, I want to write it twice. I want to write it once without the absolute value exactly the same, so that we have 4x minus 9 is greater than 3. And then another way with two changes. So same argument in the absolute value, 4x minus 9, but instead of a greater than, I'm going to have a less than. So I flip my inequality, and instead of a negative 3, I'm going to have, no, instead of a positive 3, I change the sign, so negative 3. Okay, let's go ahead and solve. So I want to go ahead and solve for x now. So I want to get x by itself for that first equation. I want to add 9 to both sides to get 0. And I'm left with 4x is greater than 12. Divide by 4, divide by 4. X is greater than 3. All right, so that's my first part. For my second one, I want to go ahead and same idea, solve for x. So I add 9, I get 0. I add 9, I get 6. 4x is less than 6. Divide by 4, divide by 4. X is less than 6 over 2. And always simplify your fraction. This is x is less than 3. Oh, I simplified it, didn't finish. Six over 4. Now we simplify our fraction. So we have x is less than 3 over 2. All right. It's not asking us to graph, but I need to graph it because I need to see what we're working with. So let's draw a number line. We have 0, and we have a number positive 3 to consider. And 3 and 1/2, which if we write it as a mixed number, it's 1 and 1/2. 3 over 2 is 1 and 1/2. So 1 and a bit more, that's right here, 3 over 2. Okay, so also with inequality, I have to attach if it's an open circle or closed circle. Because there's no equal to, they're open circles. So I have an open circle at 3 over 2 and an open circle at 3. My first argument says x is greater than 3. So I'm going to shade towards the right. My other argument says x is less than 3 over 2. So I'm going to shade towards the left. So there we have our graph. Our graph helps us come up with what our answer is. So there's two ways of writing it, interval and set builder. Your test will ask for set builder. I like to throw an interval as well because you'll see that a lot more when you go on to maybe like college algebra, pre-cal, calculus, you'll see interval a lot more. All right, so set builder would be x such that, and then we write our answer in our brackets. What is our answer? Our answer is x is less than 3 over 2 or x is greater than 3. That's set builder. That's how you'll see it in your test. Interval is how we read our answer So looking at this, I see it goes on for negative infinity to the left, and it goes on to positive infinity to the right. And there's a stop in between where the big circle, where the open circles are. So interval notation would be negative infinity to 3/2. Infinity is always used parentheses. The 3/2, because it's an open circle, it translates to a parenthesis. We have a break, so we draw U for union. It continues on from 3 and then goes on to infinity. And infinity is always use parentheses, and that 3 was an open circle, so we also use parentheses. All right, that was problem 2. I think this one is one that I would for sure be careful when I see it on the test. Whenever I see an absolute value and an equality sign, I should be extra careful. So, next question. Determine if the given number is a solution of the given equation. 4x plus 40 equals 70. All right. So all it's saying here is we need to plug in this number and we need to see if the statement is true, if it does equal 70. So let's go ahead and work this out. So I have 9 times, and instead of x, I'll write 4 plus 40 equals 76. But our big question is this true? Does it truly equal 76? All right, well, 9 times 4 is 36. 36 plus 40, does that equal 76? Yeah. So we would say something like, yes, it is a solution. It's multiple choice, so you'll see maybe like a yes or a no. That was the next problem we're going to do today. Next problem with the asterisk is 5. Graph the function f of x equals x plus 4 and complete the chart below. So I made this review totally having the test in mind. This is a problem you'll see on the test. So your test is going to give you like a chart. And it's going to have some numbers spelled out for you to do. So numbers may be like 0, 2, and 4. It would vary from problem to problem for sure. And this is your problem. What you have to do, like what you have to fill in is fill in what is your answer. That is what this question is making you do. And then after you complete this part, translate those points and graph them. Okay, so let's go ahead and figure this out. Let's do the work. So what do we get when we plug in 0? When x is equal to 0. So let's plug in a 0. F of 0 is equal to 0 plus 4. We just get 4. So we write in 4 there. Next one, what if I plug in a 2? F of 2 is equal to 2 plus 4. That gives us 6. So we write a 6 in that box. Next one, 4. X equals 4. F of 4 is equal to 4 plus 4. We get 8. Pretty straightforward, right? I think you saw this in your homework for sure. I think all these problems you saw in your homework. All right, and then from there, you want to take those points that you have, 0, 4, 2, 6, and 4, 8, and graph them. All right, so I drew a quick little grid. Let's go ahead and plot our points. So for this one, make sure you're able and are okay with, picking a point, dragging it, and plotting it on the Cartesian plane that MyMathLab gives you. So that we have 0, 4. We have 2 up 6. And 4 up 8. And we see we get a line. So this would be a problem you would you would see in your exam. And all these problems, they're like the ones in your exam. They'll just be mixed up every time you take the test. You're giving two opportunities. All right, next problem I wanted to do with you. It's asking to use the graph of the function f shown on the right to find f of 1, f of 2, and f of 3. So I didn't put a picture here because it's going to vary for person to person, right? But what it's going to do is it's going to give you a graph. Let's say something like so let's say it gives you this squiggly graph here. It can be any shape. Now, all it's asking us to do is to identify those values, f of 1, f of 2, f of 3. So I threw in some points here to show you what it'll look like. And then and it'll be a much better graph. There'll be grids everywhere so you can easily pick out these points. With these points that I drew, I meant them to be 1, 1, 2, -3, and 3, 2. Now to answer this question, it's giving you the x and it's asking for the y. So we're trying to find the y, which is the f of the number. So for the first one, f of 1, we see that at 1, we have a corresponding 1, which is your y. So our answer would be 1. At f of 2, let's take a look at the point 2. At 2, we see that my y is 3. So f of 2 would be -3. For my third point, f of 3, we see that my corresponding y is at 2. So f of 3 is equal to 2. And that's what that question is asking for. And I didn't include a picture there because it's going to vary, but it's going to give you some picture, and then you have to look at the x-intercept and see where that y coordinate aligns with. What point is that? It's helpful if you make it a point to think, okay, what point is this? This is point 1, 1. This is point 2, -3. This is point 3, 2. That's helpful. Any questions about 6? Okie dokie. All right, next on our list to do is number 9. So unlike our last problem with the inequality, here we have an equal sign. And equal signs are not as stressful, are not as tricky. All we have to do is make sure to isolate the absolute value, get the absolute value by itself. So I want to get the x plus 2 by itself. To do so, I need to move the 8. So I go ahead and do -8, -8, -8, so that we get x plus 2 absolute value is equal to 8. Once we do that, because it's an absolute value and we don't know if we're working with the positive value of it or the negative value of it, we have to consider both options. So one will be the same, x plus 2 equals 8, so the same without absolute values, and the other, I would just set it equal to the negative option. So I have x plus 2 is equal to -8. And then we solve. Let's go ahead and solve. So I subtract 2, x is equal to 6. Subtract 2, x is equal to -10. And those are our two answers for this absolute value equation. Okay, next one. Find the equation of the given points, -8, -8, and 9, 9. Okay, so I want to find the equation. To create an equation, I need to start off by, so this is your game plan. You first want to find your slope, and second, you want to create a line using your slope and a point. So we're going to use the point slope formula. Y minus y1 is equal to m times x minus x1. Maybe I should write my slope formula too. M is equal to y2 minus y1 over x2 minus x1. All right, let's start off by finding the slope. So I have these 2 points. I need to find the slope. I'm going to label them because if I don't label them, I will make a silly mistake. So I have x1, y1, x2, y2. All right, let's go ahead and find our slope. So again, our formula is y2 minus y1 over x2 minus x1. So y2 is 9 minus y1 is negative 8 over x2 is 9 minus x1 is negative 8. Let's see what we get. So 9 minus 8, so we have those two negatives. They make a positive. So we have 9 plus 8, which is 17. Same thing on the bottom. 17 divided by 17, we get 1. Our slope is equal to 1. Okay, now let's go ahead and use our point slope formula to create the equation of a line. And you can use any point you want. I'm going to choose to use this point 9, 9 because it doesn't have negatives. So maybe when I plug it in, it'll be easier for me to work with. All right, so let's go ahead and use our point slope formula so that we have y minus y1, my y is 9, is equal to m, which is 1, times x minus x1. I'm using this point, so my x is also 9. We distribute the 1 so that we have 1x minus 9 is equal to y minus 9. We add 9 to both sides. That gives us 0 and 0. We're left with y is equal to 1x, so we can just write x. And that's our answer. Okay, next question. Find the domain of the function. So for this problem, the domain, your domain is saying, so this says, what can x be? That's a domain question. Now, domains, I remember when I was in your shoes, there were that one thing I didn't like, I kind of just glazed over, but domains never go away. So the sooner we get it, the better. Domains are what can x be? And you want to look at your equation and you take a look at where x is and the spot it has. So we only have an x right there in the denominator. And we see that x, it doesn't matter what it is, but it can't ever give us a 0. Because if I end up with a 0 in the denominator, that will make it so that it's undefined. So all we have to do is see when our denominator is equal to 0. So I have x minus 12, find out when it's 0, and that's the only point that I can't have. All right, so let's solve for x. Let's add 12 at 12. X is equal to 12. So x cannot equal 12. So we can say something like all real numbers except 12. Also, you can graph it, and graphing it kind of opens your eyes as to, oh, okay, this is what it really means. So it can be all the numbers except 12. So it can be any number to the negative, any number to the positive. It just can't be 12. All right, next question. So you're going to have a question that's asking you, is this graph a function? Well, what does it mean to be a function? A function is a special relationship between x and y. It's going to give you a graph. When we're using a graph, particularly, we can use the vertical line test to show if we have a function or not. Your vertical line test says that graph is a function if a vertical line crosses the equation only once. Only once. So let's take some pictures and let's consider if they're a function. So let's take a parabola, a circle, a sideways parabola, and a line. Let's consider all these pictures and think, are they a function? So my first graph, I draw a vertical line, and no matter how many vertical lines I cross, I only cross my graph once, right? So because of this, I can say, yes, it is a function. Let's take a look at a circle. We'll graph circles at the end of this class, which it's one of my favorite sections. So when I draw a vertical line, I just draw one and we're in trouble, right? This one's not a function. What about a sideways parabola? Same deal. I just need one graph to cross to one line to graph it twice. Can't speak. I just need one vertical line to cross our graph twice for it to not be a function. So this is also not a function. What about a line? Yeah, I can draw as many vertical lines as I want. No matter how many lines I draw, I only cross my line once. So this one is a yes, it is a function. That's the type of question you'll see. I'll give you a picture and say, hey, is it a function? Or you call, okay, it's a special relationship, particularly our x values do not repeat. And we recall our vertical line test. All right, number 15. Solve the following inequality. X minus 10 is less than 7, or x minus 4 is greater than 1. So for these questions, I solve for both of these equations separately, and then at the end I graph them. Now your argument tells you a lot. So because we have or, this tells us what we're looking for. And our answer would be anything that's shaded. Okay, let's solve each one separately. So I have x minus 10 is less than 7, or x minus 4 is greater than 1. Okay, let's go ahead and solve for x. So we have plus 10, x is less than 17. 7 plus 10 gives us 17. That's our first answer. Then I have x minus 4 is greater than 1. We add 4 to both sides. X is greater than 5. Let's go ahead and graph these. So I have 5 and 17. For our first one, 17, x is less than 17. Because there's no equal to, I use the open circle and I shade to the left. For our next one, x is greater than 5. So I'm going to circle 5 with the open circle since there's no equal to, and graph to the right because it's greater than. All right. Now, because we have or as our argument, we want to consider our answer to be anything that's shaded. Now, looking at this, we see that, well, everything is shaded with the exception of our points, with the exception of that 5 and that 17. So their answer is, well, we go to the left forever, so I have negative infinity, and I go to the right forever, so I have positive infinity. So it goes on for negative infinity to 5. Then we take a break because I have an open circle, so that's a stop in our graph. We have a break, but from there we continue. So from 5 to 17, and then we have another break. And then to 17 to infinity. We have parentheses because none of these had an equal to. If they were equal to, we'd use a bracket. Now, how do we see this in Set Builder? Set Builder is we draw a curly bracket X, such that line and curly bracket. Now we write our answer in that space. So our answer is X is less than 17 or X is greater than 5. That would be Set Builder. Last question we did together, 19. Negative 11 is less than or equal to negative x plus 4 less than 0. Okay, so for this problem, it looks a bit different. It's given as a compound inequality. Compound inequalities always refer to AND arguments. Okay, let's go ahead and solve. Just treat this as it having two equal signs. Or if you'd like to, you can draw a line so you can keep track of all the work you're doing. Remember to do everything to all three sides. So that we have, our goal is to get x by itself, so let's go ahead and move that 4. So minus 4 to all three sides. 4 minus 4 is 0. 11 minus 4 is negative 15. Is less than or equal to negative x. Is less than 0 minus 4 is negative 4. Okay, I'm going to draw a star because I see that I have to divide by a negative x or negative 1 to get x by itself. What happens when you divide by a negative and we have inequalities? They flip. So we have negative 15 divided by negative 1, we get 15. It's greater than or equal to x. It's greater than 4. Okay, let's go ahead and graph our inequality. So what's cool about compound inequalities is they tell you what it's sandwiched between. So here we have 4 with the open circle and 15 with a closed circle because I have equal to. And our answer is everything in between. That is our AND argument for this compound inequality. And that is our answer. How do we write in Set Builder? It'd be x such that, and then we write our answer, whatever we got. So I want to make sure they're pointing to the left. So I would have 4 is less than x, less or equal to 15, and then close your curly bracket. Okay, so this is your exam 1 review. Are there any questions or are there any problems you want to see done before we take off from our Zoom meeting? All right, so if something pops up, email me, it's fine. Or if you're typing, type away. I'll linger for a moment in case you have questions. So again, your exam is on MyMathLab. It will be available from noon. So I was anticipating, just in case we go for 2 hours or you have more questions, it'll be available at noon. and you'll have until October 1st, so a week from now, to finish it. Now, your exam is going to be chapter 2, chapter 1 stuff all mixed up. So that's why I made your review with all these concepts mixed up. Yeah. You'll have 3 hours, 2 attempts, and I think that's all that I need to ask or say. Are there any other questions about your test? Okay, so I'll go ahead and stop the recording. I'll linger for a couple of minutes in case you have any questions. But that's it for a Zoom meeting. Thank you so much for showing up. You have these pages in this week's module in the page for our Zoom meeting where I have that announcement about our Zoom meeting, and I'll also post on that page this recording, and I'll make an announcement once that recording is available.